Hey class, this is section 8.7, which is about dilations. We started talking about dilations as a size change transformation. And whenever your size changes but the shape stays the same, that's also known as a similarity transformation. Okay, a few other vocabulary words that you want to know for this chapter. Center of dilation is always the point in which the dilation is fixed about. So if you think about your eyes getting dilated, that would be right in the center of your pupil. The scale factor basically just describes how much are you dilating the shape by, how much are you changing that size. And the scale factor is always represented by a ratio of the image length to the corresponding pre-image length. So here's an example. Your scale factor, in this case, if this is the image and this is your pre-image, would be JK to AB. There's two types of dilations. It either can be an enlargement or a reduction. An enlargement occurs when your scale factor is more than 1, so it gets bigger. A reduction occurs when your scale factor is between 0 and 1, so it gets smaller. For our purposes, instead of writing out the word scale factor every time, we will just be representing that with the letter K. Okay. Graph your 3 points for example 1, and then it also tells us that K is 1/2. Remember that this is our scale factor, and since it's between 0 and 1, we know that this is going to be a reduction. It's going to get smaller. Okay? Just like you did on that activity, you're going to take each of these coordinates and you're going to multiply by the scale factor. So that will give us our image points. A prime, 2 times 1/2 is 1, 4 times 1/2 is 2. Then you're going to graph A prime. Same thing for B prime. 4 times 1/2 is 2, and 6 times 1/2 is 3. And then lastly for C prime, 3 times 1/2 is 1.5, and then negative 1.5. Once you have your 3 points, then all you need to do is connect it with a ruler, and it should look similar to the shape that you started with. And this should be your image of your dilation. A couple things to take note. Your shape shouldn't look distorted. It should look the same shape as what you started with, just a little bit smaller or a little bit larger. Another way you could check your answer is if you connect the center of dilation, which will be the origin, to your image and pre-image, it should form a straight line, just like we were showing in class. It kind of looks like three-dimensional, or those of you who have done a perspective drawing might look something like that. Okay, see if you could try the others. Those of you that already completed example number 2, again, it should look exactly like the shape that you started with. Nothing should be distorted. So you can tell right away that this example here, it's just getting a little bit larger. Here are examples 3 and 4. Just a couple things to keep in mind. Make sure that when you do your dilations, your image should always have the prime symbols on it. Okay? Dilations can also be done off of the coordinate plane, so these problems are from the worksheet 8.7c, day 2 homework. Okay, so if I give you just an ordinary picture of a dilation that's not on the coordinate plane, you can't really use the coordinates. You just have to go by the symbols and the measurements that you see. So first of all, P to P prime, clearly it's getting larger, so we would say that this is an enlargement. And then you have to also find the scale factor, so that's K. Again, we're going to do the image, so P prime, that length there is 12. The pre-image length is 8. And then simplify. 3/2 or 1.5 if you'd rather. Okay? See if you can try examples 2 and 3. Okay, number 2 is an enlargement just like number 1, but number 3, you can see from P to P prime the shape is getting smaller, so that would be a reduction. that means that your scale factor should be between 0 and 1. Questions 4 and 5 are just like 1 through 3, but then it also asks you to find some missing parts. So first of all, p to p prime, it's getting bigger, so that's an enlargement. And it is getting bigger by a scale factor of, I'm going to choose these two sides because those are the only two sides that both have numerical values. So k is equal to 12 to 4, which is 3. That means my scale factor is 3. This shape is getting bigger by 3 times. So if this side here is 5, that means that x is going to have to be 5 times 3. So x is going to be 15. And then to find y corresponds with this side, that's 6. So that means y is going to have to be 6 times my scale factor of 3, so 18. See if you can try example number 5. For example number 5, I can see from p to p prime it's getting smaller, so that would be a reduction, which means, again, your scale factor has to be between 0 and 1. So that means if I look at these corresponding sides, 5 to 12, and then I can use that scale factor to figure out my value for x. Okay, example number 8 is now asking you to use a ruler to draw this dilation if the center of the dilation is A and if the scale factor is 2. This means that it's getting larger. Okay, the first thing that you need to do is connect your center of dilation to each vertex of the shape. And since we know it's getting larger, you just want to extend that ray a little bit. Okay, now your second step, so step 1, draw the rays. Oops. Through each vertex. Step 2 is to measure. Measure the distance from your center of dilation to each vertex. Okay, so go ahead and do that in centimeters. Okay, so when I measured that, I got that AN was 1 centimeter, AO was 3 centimeters, and AM was 1.3 centimeters. Now I need to use those measurements with my scale factor to figure out what my new measurements have to be. Well, if my scale factor is 2, I'm just going to multiply these by 2. And then I'm going to measure from A out to N prime 2 centimeters. Okay, so 2 centimeters, it's going to be right here. Label that as N prime. Now I'm going to do the same thing for O prime and M prime. So you should now have something that looks like this. Your very last step, so mark your prime points by multiplying those measurements by your scale factor, K. Then connect all your points. And then you'll have your final dilated figure. And this is what you should end up with at the end of your dilation. I definitely would recommend that you write out these measurements off to the side, or you can write the measurements right on your diagram, but that might get a little bit busy. So putting them off to the side is a little bit easier to organize. Okay, see if you can go ahead and try questions 9 through 11, and then resume the video to see how you did. Here are the answers to questions 9 and 10. Be careful, even though 3/2 looks like a fraction, it is greater than 1, so this shape should be getting larger. And since your center of dilation is one of the vertices, that point does not move at all. In question number 10, the center of dilation is inside of the figure, and it is a reduction, so it should be getting smaller. For question number 11, it asks you to locate the center of dilation, so that point. And the way that you would find that is by connecting your prime to your pre-image vertice, connect them all, and they should all meet at one point. That would be your center of dilation. I hope that this video helped you guys out in understanding dilations, and if you need any more help, please come see me to schedule an appointment.